I'm going to continue talking about proportional scaling in this movie, but show you yet another approach. In this case, it's a very specialized approach. We're going to leverage the built-in behavior of the spline object to help us control scaling of the forms that we generate from them. So I'm in a file called spline, and spline was generated from our GM seed file, and I just made a couple quick modifications. Let me just point out what those are. I've tied W and D together in family types by adding a really simple formula that just says they're equal to one another. So D is equal to W, and then I flexed them to 1.75. I also added an H parameter, and you can see that I've applied that here in the front view to this reference plane right here. Now I'm going to do my work in the front view and widen the front view out, zoom in a little bit, and I'm going to add one more reference plane. So that reference plane is going to be just to the right of center, and I'm going to make that 0.25 units. Add a dimension from the center to the reference plane. Let me just kind of put that down here somewhere and label that with a new parameter that I'm going to call x1. I'm going to put that new parameter under constraints and click OK. All right, so I only need x1 on one side because the form I'm going to create over here is a revolve. And a revolve, you draw basically half of the shape that you want to revolve. So I'm going to be drawing the shape over here on the right side of center, and it will revolve a full 360 degrees. So that's why I only need one of these reference planes. So the next step is for me to go to the Create panel and click the Revolve tool. Now, if you've worked in the Family Editor before, you know how important the work plane is. So I'm in the front view. Revit will automatically default to the default reference plane that happens to be parallel to the front view. And if you look over here on Properties, that is the center front back reference plane. So it's defaulting to that work plane. If I don't like that choice, I need to click the Set Work Plane button right now and choose a different work plane. But in my case, that's a perfectly fine choice, so I'm going to accept that. So the next thing that I want to do is go to my spline command. So the spline is a very specialized kind of curve. You can see from the description there, it's a smooth curve that passes through points. Now this is a two-dimensional spline, so we're going to be drawing all the points in a 2D plane, our work plane in this case. And I'm going to make sure that the first point of my spline is at the intersection of that top reference plane and the one that we just drew. So I'll click right there. Now, you can draw as many points as you want in the spline. Maybe I'm drawing a baluster. Maybe I'm drawing the base to a lamp. Maybe I'm drawing a bowling pin. Whatever it is you're drawing, it's basically a free-form shape. So you can add as many points as you like here and start to give this shape some curvature. And you can always come back and fine-tune it after you create it. And I just want to make sure that the last point ends at the intersection of the reference plane we just drew and the bottom reference plane. And I'll snap right there and click my Modify tool to cancel. Now, if you want to fine-tune, you can click on it and you get these little shape handles here that allow you to customize the degree of curvature just by sort of picking and pulling and adjusting until the curve suits your desired shape. So it takes a little bit of fine-tuning to do that. So once you're happy with the shape, you can move on to the next step. The idea behind a spline is quite simple. The splines have a built-in superpower, which scales proportionally automatically. In other words, that's just what it does unless you tell it otherwise. So I can demonstrate that really easily by selecting the spline. I'll zoom out a little bit, and I'm going to grab this endpoint at the end here and start to drag it. And what you'll see is as I drag this, the shape of that spline, even if I drag at an angle, is being maintained. So all of those intermediate points are unaffected. They all scale proportionally as you stretch the shape. Now, that's great. That's the feature I want to leverage. But what I want to do is make sure that it doesn't distort in some other angle. So I'm going to lock it down, just like we've done with other curves. So I'll zoom in at the top here, go to my Align command, lock that endpoint in both directions. Be careful. I just selected the spline. That's not what I want. So I'm going to click an empty space. Make sure I pick the reference plane first, then the spline. Very important that you do that. So instead of pressing the escape key, which a lot of folks are in the habit of doing. If you accidentally pick the wrong thing, before you click anywhere else, just click an empty white space. That resets the align command. And then you can pick the right thing, which was the reference plane and then the point. The reference plane and then the point. All right, so let me cancel out of there. Now, before I can complete the shape, I have to have a closed shape. It's just like any other 3D form. So I'm just going to go back to my boundary line button here. I'm going to do straight lines for these, and I'll pick a point right at the top, snapping directly to the spline, come back to the middle, pull it straight down, and then go back right here. So I'm just going to kind of create those three sides and then align and lock them just to make sure that they stay put. So again, reference plane to sketch, reference plane to sketch, and then lock. So that's my shape. But I still need to show it the axis that I want it to revolve around. So I click the axis line button here on the ribbon in order to do that. And I don't usually like to draw it right on top of another line because Revit complains and tells you have two lines on top of each other. So I usually just draw it over here somewhere. Doesn't really matter where you draw it as long as it defines the axis of rotation. So by having it up here, it still does that job. It's just out of the way. And I'll align it and lock it like so. When I click finish, it will revolve that shape around. And when I look at it over here in 3D, I have the base of my lamp or the baluster for my railing or whatever this 3D form happens to be. So there's one more step I need to do before we flex it. We added this X1 parameter, but if we go to family types, we have not given it a relationship yet. So the spline will scale proportionally on its own, but that back distance, that little flat horizontal distance, will not. So in order for that little flat horizontal distance to behave, we need to give it an appropriate proportion. So you can tie this X1 parameter to any of the other values, but I'm going to tie it to the height. So I'm just going to simply say h divided by 20, and that's the relationship that it currently has, and I want to maintain that relationship. So h divided by 20 gives me that value. I'll click OK. And now when the height flexes, it will flex the spline, which will in turn flex the X1 dimension. So let's give it a test over here. I'm going to do the 3D view to see this. Let's zoom in a little bit. Go to family types. Let's try a height of 7. Click apply. You see it change proportionally. Let's try a height of 3. Click apply, and you see it change proportionally. So the X1 is using the formula like we did in some of the previous movies, but the spline is really doing the heavy lifting here. To get that really intricate curvature in there and that very complex shape, all we had to do was sketch it out with the spline. If you tried to do the same curve using arcs, you'd need lots of little arcs, and every one of those arcs would require 3 things to constrain them, as we've seen throughout the course. It could be the center, or it could be the arc, or it could be the endpoints or the radius. It could be any of those things, but each arc would need 3 things. That's a lot of reference planes, a lot of trigonometry, a lot of calculation. So while I think those are all valuable tools and very stable tools, sometimes you can avoid all of that by just picking the right tool for the job. And in this case, a form like this, a spline works perfectly well for this, and you can use that, and the formulas become very simple because they're not necessary.